All right, so number 1 says graph the triangle ABC with the vertices that are given and then classify it by its side and sides and determine if it's a right triangle. So this was like the one that was in the homework. So I'm going to take a graph because I want to be as accurate as I can to get the visual. 0, 6 will give me a point that's here. This is A. B is -4, -1. And C is 4, -1. So the first thing I got to do is classify this by its sides. How am I going to do that? What do I have to know about these sides? Have to know how long they are, right? How do you figure out how long those sides would be?
The distance between 2 points.
Good. Distance between 2 points. So B and C, I got lucky because what's true about B and C? What's true about that line? It's horizontal, right? So do I have to do the distance formula there? No, I can just count it, right? So if I were to count from left to right here, I'm going from -4, 1, 2, 3, 4, 5, 6, 7, 8 to 4, or 4 minus a -4. That tells me BC is 8. And then I've got to find the length of AB and the length of AC. So AB, and this point was -4, -1, and 0, 6. So square root of x2 minus x1 squared plus y1 minus y2, or sorry, y2 minus y1 squared. And it doesn't matter which ones I make my 1s and my 2s as long as I'm consistent. So the b's were both in first in both. So this is -4 squared plus -7 squared, 16 plus 49, which is 65. So already you're ruling out that it's what kind of triangle? Good. Can't be equilateral, right? Because those two are not the same. Okay, then I want to find AC. So C was 4, -1. I can do the square root of 4 minus 0 squared plus -1 minus 6 squared, 4 squared, plus -7 squared, and again, 16 plus 49 is the square root of 65. So what do I know about this triangle? It's isosceles. That's the first thing I can figure out. Okay, the second question is determine if it's a right triangle. Kind of just by looking at it, you should know it's not, right? But let's say it's close. If I wanted to prove that it was, how would I know if it's a right triangle? And let's pretend you've never heard of Pythagorean theorem if you've heard of it. Okay, let's pretend that we don't even know that yet. How's another way to show that something has a right angle? Okay, let's say you don't have your protractor handy. The slope of two perpendicular lines would be opposite reciprocal, right? And if they're perpendicular, then what's true about the triangle? There'd be a 90-degree angle, which would make it a right triangle. Yeah? So if it was close, let's say that it appeared as though maybe these two lines here could be perpendicular, then I would find the slope of this line. I would do 6 minus a -1 over 0 minus a -4, and I get 7/4. And then I'd find the slope of this line, so -1 minus a positive 1. No, -1 minus a -1, and then 4 minus a -4, and I get 0 over 8. So these are clearly not opposite reciprocals, which makes you know that those lines would not be perpendicular. Okay, again, from the diagram, you can pretty much rule out that it's a right triangle. But if you didn't have a diagram or you wanted to prove it, then you would have to find the slope of at least two sides and show that they would be or not be opposite reciprocals of each other. Questions so far? Okay, so then 2 says, find x and then classify the triangle by its angles. So what do I know about all three angles? They add up to 180, so 50 plus 3x plus 20 plus 2x equals 180. Combine my like terms, 5x plus 70 equals 180. 5x equals 110, and x would equal 22. So that's the x, but now in order to classify it, you have to know what? Plug it back in. So this would be 44. This would be 66 plus 20, which is 86. What do I know about this by its angles? It's acute. Okay, by sides it's scalene, right? But by angles it's acute. Questions on 2? Okay, 3 says find the measure of the exterior angle shown. So what's it called when we find the measure of the exterior angle? What's the theorem that we use? Exterior angle. What are we doing with those other angles? Sum. Exterior angle sum theorem. Okay, so we're saying that this is equal to the sum of these two, right? So x plus 72 equals 40 plus 2x. Subtract the x. 72 equals 40 plus x. Subtract the 40. 32 equals x. But it doesn't ask for the measure of the x, right? It asks for the measure of the angle. So I'm going to take and plug that in. 32 plus 72, which is 104. So be really careful. That would have been like something an SAT would do. It would give you a diagram. It would have you solve for x, but it's not asking for x. So pay attention to the wording on it. Same thing in multiple choice. It's going to make you plug it back in. And if that was multiple choice, A is going to be 32. And you're going to see 32. You're going to get excited. You're going to circle it like you got it right. And you're wrong, right? So don't let it happen. Make sure you read very carefully. Okay, so then 4 says find x and y. So there's a lot going on in here. I can actually take this triangle and divide it into 2 triangles, or I could divide it into 4 triangles, or I could divide it into different little, like the 2 little ones at the top with 1 on the bottom. So there's a lot of different ways to draw these out. They're always going to give you just enough information to at least get something going, okay? So what do we know about this diagram? What can you tell me about it before you even get to the x and the y?
Well, that 32 plus 50 is going to give you that.
So if I use this triangle, 32 plus 50 is going to give you not x, right? Is that what you're talking about, this one?
Yeah.
Okay, so 32 plus 50 is going to give you the linear pair of x, right? Yeah, so 32 plus 50 is 82. Subtract that from 180, and I get 98 for this. And then 32. Is that what you're saying? 32 plus 50 is going to give you x because it's the exterior angle?
Yeah.
Okay, so that's the other way. So 32 plus 50, which was 82, also gives you x because that's the exterior angle of that triangle. Okay? Or you could have found 98 and subtracted it from 180. What other piece of information is there that you need, Sarah?
Where it says the right angle, the other side also a right angle.
Good. So this would be 90, which means this is 90.
And then if you add 90 and 32, you'll get the vertical angle.
Good. So now you've got this little triangle here at the top. 90 plus 32 is 122. Subtract that from 180, and I get 58 for the angle in there, which are vertical angles with y. So now y is 58. Okay, you also could have used this triangle here, right? Once you had 50 and 90, add those together, 140, and you would have gotten that angle, and then added that to the 82 to get the 58. So you can do these a lot of different ways. Chris?
I get how you found y, because I just, like the first way you did x.
Yeah. So there's 2 different ways to look at it. You could have either done that x is the exterior angle on the triangle to the right. So if I look at that triangle, if I look at this triangle here, right? Then x is the exterior angle of that triangle, which means it sums up to the 2 non-adjacent interior angles, which would be 32 and 50. So let's say you forget that theorem. The other way to look at it is that this is a triangle here. 32 and 50 is 82. Subtract that from 180. And you should get that this angle here, right, because 82 subtracted from 180 would be 98. And then these 2 angles are a linear pair, so they add up to 180. So that's the other way to get it. 82. Nope. This is 8. This is 2. Okay? So the thing about all these triangles is that no matter how you look at them, all those same rules apply. So the triangles are always going to add up to 180. Okay, your exterior angle is always going to be true. Vertical angles are still always true. If it's perpendicular on one side, it's going to be right angle on the other side. So all that stuff gets applied and carried over. You just can't forget about it. Your linear pairs are still going to be true, even inside a triangle. You just got to be careful. All right, 4.2 is called applying congruence in triangles. So we're going to start with our congruence stuff. If I identify two triangles or two polygons really, even as congruent, and then we're going to narrow it down to just the triangle. So two congruent figures are congruents that have the same size and shape, which we've talked about before. If I'm comparing a triangle to something else that's congruent, it has to be another triangle. If I'm comparing a quadrilateral, it has to be compared to a quadrilateral. Okay, hexagon to hexagon has to have the same size and shape. If they are congruent, then all of their corresponding parts match up. So each side in the one would match one side in the other, and each angle in the first would match one angle in the other. So individually, how you name a triangle, the letters do not matter. Okay, if I call that triangle ABC, is it the same triangle if I say BCA? If I say CAB? Same triangle, right? But when I go to say that triangle ABC is congruent to FED, now the letters are important. So whatever you establish for the first one, if I call that first triangle ABC, and oftentimes your book will go in alphabetical order first, okay? Wait for it. If I call that triangle ABC, then again you have to pay attention to the order of the letters. So A, if I look at the little angle marks, how many tick marks does A have? 1, which means when I go to name the second triangle, I have to go in the same order. So what letter on the second triangle has this 1 tick mark? F. Now if I go to B, B has how many? 2. What has 2 on the other one? E. And the third one is obviously C, which would match D. Okay? So the letters matter if you're saying that they're congruent, and they have to match up. Okay, I could have looked at it with the sides too. Sometimes you don't have the measures on the angles, you only have them on the sides. So I said AB first, which is the side that has 1 tick mark. So the first 2 letters should have been FE, which they were. And then BC comes second, that has 3 letters. ED comes second, that has 3 letters. Okay. So again, the order of the letters is super important when you're making a congruent statement, which is what that's called. So when it says make a statement of congruence, this is what it means. This is your statement of congruence. What triangle is congruent to what triangle, and the order of the letters is important. Third angle theorem says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. We could have easily proven this one, right? If I said that on one triangle my angles were 30, 60, and 90, and then on the second triangle it was 30 and 60, I could say 30 and 60 plus that last angle have to add up to 180 and subtract the other 2 to get it. But this is a shorter way to do it, and if you don't have values, this is the only way you can do it. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So in this case, if you were given A is congruent to D and B was congruent to E, then you can state C is congruent to F, and your reason is third angles theorem. And you can shorten it. You can write third angles theorem. I know what you mean. Okay. So this should be a review. Properties of congruent triangles. We've talked about these several times. Reflexive, symmetric, and transitive. It's just that now we're saying not only do they apply to variables, but they also apply to angles, and they also apply to segments, and now they apply to triangles. So if 2 triangles are equal to each other, or sorry, a triangle equals itself, that's the reflexive property. If triangle ABC equals C is DEF, then DEF equals ABC, that's symmetric. And if triangle ABC equals triangle DEF and DEF equals JKL, then ABC equals, or is congruent to JKL, that's transitive. All right, so we're going to fill these in with always, sometimes, or never. Let's see how well you know this stuff. Number 1 says an acute triangle is blank congruent to an obtuse triangle. Never. Is it possible for an obtuse triangle to equal a triangle that has all angles underneath 90 degrees? No, it's not possible, right? A polygon is blank congruent to itself. Always. A right triangle is blank congruent to another right triangle. Good, sometimes. If triangle ABC is congruent to triangle XYZ, then angle A is blank congruent to angle Y. Think about it. Sometimes. When would it be sometimes? When they have the same measure. So if two angles have the same measure, then what kind of triangle is that? Good. Okay, we haven't even gotten to it yet, but if you think about it, it has to be isosceles. So this is sometimes. If triangle ABC is congruent to XYZ, then A is blank congruent to X. Always. Good. So remember, the order matters. If it's the first letter here, then it equals the first letter here. Questions on any of those? Okay, this one says in the diagram, A, B, C, D, so now we're talking about a quadrilateral, is congruent to F, E, F, G, H, K. Find the value of, oh, you don't have that. All right, so if it gives you a congruent statement, pay attention to the order of the letters. One, you may not get a diagram with it, and so you'd have to know that A matches F, and B matches G, and C matches H, and D matches K. Or you might get a diagram that does not look that different from one another. Okay, like these kind of appear to be like you could match up which one was congruent to which. But you might get triangles that are turned different ways, and it might be hard to match up lines. And that's where the congruent statement is going to come in handy. So if I've got X on this side here, what side does that match in the other quadrilateral? The 9 inches. So all I have to do is say that 3x minus 6 equals 9, 3x would equal 15, and x equals 5. And then the other question is based on an angle. So again, all the corresponding sides are congruent, and so are all the corresponding angles. So angle K, I can either do it from the picture or from up here. Angle K would match what? 44, which is angle D. So 4x plus 2y would equal 44. I already have the x, it's 5. So sometime it won't matter what order you put them in, but this time obviously it does because you needed the x. Subtract that 20 and divide by 2, and y equals 12. Questions on any of that? Good. Maggie took the piece of fabric STUV shown in the diagram and cut it on the diagonal to make a scarf for her and a friend. Are the two pieces the same size and shape? And explain. So in order for them, we will eventually learn shortcuts to proving triangles are congruent. But for right now, the only way you know how to prove these are congruent is if all 3 sides match and all 3 angles match. So if I go around this shape, do I have 1 tick mark in the left one and 1 in the right? Yes. So I know that SV is congruent to TU. And then I've got the double tick mark up here, ST, matches the double tick mark here, which is VU. That's 2 sides. How about the third side? Would they be congruent in each triangle? Is SU congruent to SU? Yeah, how do you know that? What's it called? Reflexive. So if I was proving this, right, then I would say that SV equals TU, and that's given. I would say ST equals VU, and that's given. And then I would say SU equals SU, and that's reflexive. So all 3 sides match. Now I need all 3 angles to have a pair. So which ones are already congruent without having to figure anything out? V and T are congruent, right? Because they're both right angles. They both equal 90 degrees. They both equal each other. What do I know about the other angles?
You said 1 and 2 are complementary.
So 1 and 2 are complementary, 3 and 4 are complementary. True, right? Do I know that 2 equals 3 and 1 equals 4?
Yeah, alternate exterior.
They're alternate interior, but are the lines parallel?
No.
Can you prove that the lines are parallel?
Yes.
How?
180 degrees. 90.
Two lines are perpendicular to the same line that they are parallel. Yes? Is that true? How about if angle S and angle V, if I were to take those right angles, they're both 90, if I add them to 180, what's the relationship there? What's the relationship of TSU, or TSV, sorry, and angle V? They're supplementary. What's the special angle name? Same side interior. If same side interior are supplementary, are their lines parallel? Yes. So either way you look at it, these lines are now parallel, okay? And if these lines are parallel, then 2 is congruent to 3, and 1 is congruent to 4. So I've got all 3 sides that match, and all 3 angles that match. So my answer would be yes, and the explanation is all that stuff we just talked about, okay? Or all 3 sides, all 3 pairs of sides are congruent, and all 3 pairs of angles are congruent. So we're not going to go through an official proof, but if we did, we would have to explain all those steps that we just did. Which, ta-da, happens here. So I'm going to rewrite my given SV, RV, TV, WV, and ST, RW, and T, and W. And I'm going to mark it. So this is congruent to this, this is congruent to this, and this is congruent to this. So I already have all 3 pairs of sides, and then T is congruent to W. I've got 1 pair of angles. What else do I need? I've got 3 sides, 1 pair of angles. What do I need? The other 2 pairs of angles, right? How can I show that what's in this diagram that's going on that you should be able to see right away? Vertical angles. So angle T VS is congruent to angle WVR. And that's vertical angles theorem. Now I've got 1 pair of angles left. Can I show that those 2 are congruent? How? What's it called? If 2 pairs of angles are congruent, then the third has to be. Third angle theorem. So triangle STV is congruent to triangle RWV. And my reason is the definition of congruent triangles. All 3 sides and all 3 angles have to be congruent. So the good news is on Thursday, just wait for it, we're going to start to learn shortcuts to proving triangles are congruent. There's 5 of them. You're going to eventually learn all 5 where you won't have to prove all 3. Okay, but for now you only know that way.